Welcome back to the topic of using the sine and cosine rule, and sometimes the Pythagorean theorem to find missing angles or missing sides in 3D objects. If we have a look at this question that we have in hands here, an observer at the top of the tower. The most important thing, as you're reading the question, you should be drawing a diagram for that question. So let's imagine that this is the tower. The height of this tower is 15 meter. So this is our 15-meter height of a tower. And then he sees a man due west of him at an angle of depression 31 degrees. So if we say that this is the coordinate plane and the tower is right in the middle of our coordinate at the origin point. So this is the north, this is the east, this is the south, and this is the west. Now he sees a man due west, at an so from the top of the tower down to the west. We don't know the distance from the ground of the tower to that point, but we know this angle of depression as 31 degrees. He sees another man due south, so from the top towards the south, and the angle of depression is 17 degrees. Now my diagram is ready. I can start looking for triangles so that I can apply the sine, the cosine rule, or the Pythagorean theorem. If we start with this triangle here, the tower is one side, the floor is the other side, and this is the hypotenuse from the top to this point with an angle of depression that is 31 degrees. So this is the ground, this is the tower, the angle between the tower and the ground is 90 degrees, and this is from the top of the tower to this point with an angle of depression that is 31 degrees. Can you see the triangle here? Now, if the height of the tower is 15, this is the 31 degrees. I know that we can use here that the tower is the opposite side to the 31, and we are trying to find the adjacent side. So we're going to say tan of 31 is equal to 15 over adjacent, and we find this side here. But I'm going to use the sine rule. So if this is the opposite side to 31 degrees, which is equal to 15 meter, which is the height of the tower, and this is the opposite side to angle 59, this is 90, this is 59, because the angle between the tower and the ground is 90 degrees. So this one is 59. Angles in a triangle add up to 180. So this is the side that is opposite to angle 59. Let's apply the sine rule. The sine rule states that the side over the angle that is opposite to that side. So opposite side, which is the red line here, over the angle that is opposite to the red line is 59, so it's sine of 59 is equal to this side. We named it as opposite side to 31. So the blue side over the angle that is opposite to it is 31, so over sine of 31. Let's substitute now. So the opposite side to 59, we named it as t, because it is unknown. So it's t over sine of 59 is equal the opposite side to angle 31, which is the height of the tower, is equal to 15. So it's 15 over 31 degrees. If we cross if we cross multiply, then we're going to write t is equal to fraction line. What is t multiplied by? It is multiplied by sine of 31. So sine of 31 is my denominator and the numerator is 15 times sine of 59. So we're going to write it this way. This is ready to be inserted in the calculator and t is equal to 24.96. If we want to round this answer to 3 significant figures, we're going to stop at the 9. We look to the right of the 9, which is 6. 6 is greater than 5, so it's gonna bring my 9 up to 10. So 0, 1, so 25.0 meter is the answer correct to 3 significant figures. So that is this, from this point on the ground, the point of the tower from the ground towards the west to this point of observation, this side here, the length of it is 25.0 meter, correct to 3 significant figures. So that's what we found so far. Now we need to find this side from here to here. So accordingly, we're going to take this triangle, the tower, the observation towards the south with an angle of depression 17, and with this side. Can you see? So the angle between the tower and the ground, once again, is always 90 degrees. The angle of depression here is 17. The opposite side to angle 17 is the height of the tower, which is 15 meter. And in here, I'm going to simplify it, although we can still use the sine rule, but I'm going to use the given angle and to decide if I'm going to use the sine, the cosine, or the tan of the unknown angle in order to find this side here, the red side. So if 15 is the opposite side to angle 17, then the red line here is the adjacent side to angle 17. So if the adjacent is unknown and the opposite is known as well as the angle, then we're going to use tan of the angle. So tan of 17 is equal to opposite over adjacent. If we were going to use the sine rule as we did in the previous step, then if this is 90, then this one here is going to be 73, right? So you're going to say 15 over sine of 17 is equal to adjacent over sine of 73. Please try this method as well and try to figure out if you are going to end up with the exact same answer of this method that we are using on the screen right now. So tan of 17 is equal to opposite over adjacent. Let's substitute in the rule. Tan of 17, the opposite is the tower. The opposite to angle 17 is the tower. So it's 15 over adjacent, which is my unknown. Get rid of the denominator or cross multiply. So adjacent is multiplied by the tan of 17 degrees. So adjacent is equal to and fraction line. So tan 17 is my denominator and 15 times 1 is my numerator. So this is ready to be inserted in the calculator, and if you do so, you will find the adjacent as 49.06 278928 m. And if you want to round this answer correct to 3 significant figures, you're going to stop at the 0, look at the right, 6 is greater than 5, so the 0 is gonna go up to 1. So the answer correct to 3 significant figures is 49.1 meter. So this is the side from this point to this point of observation. The length of this side is 49.1 meter. And now he wants the distance. There is a man here and there is a man here. So if we connect between these 2 points, so this is the length of this side is what I'm actually looking for. So we are going to take the triangle that is sitting on the floor. If we name this distance between the 2 men on the ground as x, and we took a sketch of this triangle that is sitting on the floor, we know that this side is 24.96 or 25.0 and this one is 49.1. So we are going to find this angle here, because this is the west and the south, and the angle between the west and the south is always 90 degrees. So the distance between the 2 men is x once again, so that's what I'm trying to find, which is the hypotenuse. I know that you can use here the Pythagorean theorem, but because I mentioned at the very beginning of this example that I want to use different methods, so we used in the first step to find the 24.96, we used the sine rule, and to find the 49.06, we use the tan of angle 17. And at last here, I want to use the cosine rule, although, once again, the x is the hypotenuse because it is right across the 90 degree. So we can use the Pythagorean, which is x squared is equal to 24.96, etc. to the power of 2 plus 49.0627, etc. to the power of 2. You substitute it or you insert this in the calculator and you will find the answer immediately. But I'm going to use the cosine rule just out of practice. So 2 unknown sides, the yellow sides here as you can see in the triangle, and 1 unknown with an angle between the 2 yellow sides, the angle is 90 degrees, and 1 unknown side, which is the x. So if we use the cosine rule states the unknown side, which is x to the power of 2, is equal to what are the other two given sides in the triangle or known sides. It's the 24.96 to the power of 2 plus the other side is 49.06 to the power of 2 minus in brackets 2 times the first known side times the second known side times the angle between the 2 known sides, which is 90 degrees. So we are solving here for x, and that's why we need to square root each side of the equation to solve for x. So x is equal to square root of the first side to the power of 2 plus the second known side to the power of 2 minus inside the brackets 2 times the first known side times the second known side times cosine the angle between the 2 known sides. This is ready to be inserted in the calculator, and accordingly you're going to find x as 55.0487 meter, and if you want to round this to 3 significant figures, you're going to stop at the 0. The 4 is not going to bring my 0 up, so the answer correct to 3 significant figures is 55.0 meter. This is a beautiful example because I used the sine rule, I used tan of the given elevation rule, and I used the cosine rule. And this is a practice for all the rules that we can use in solving problems for 3D objects. Thank you so much for watching. Please watch this video a couple of times and try to solve the exact same problem from A to Z on your own. And if you can't, you have to watch the video once again. Thank you. Please share and subscribe to my YouTube channel, and I will see you in the next video.